Hi everyone, my name is James Jones, and in this video I'll be walking you through a Java-based Gomoku game that I developed for my as a personal project based on an assignment that I had to do for my data structures and algorithms course in April 2025. The project assignment I did for my class didn't have a GUI, and I just wanted to make it a little bit easier to play and to see. So I added a GUI to this version, which features both two-player and AI gameplay, built using Java Swing for the graphical interface and powered by a custom AI using the Minimax algorithm with alpha beta pruning. Um, Gomoku, also known as Five in a Row, is a strategy board game where players take turns placing pieces on a grid. The objective is to be the first to get five veer marks in a row, whether it's horizontally, vertically, or diagonally. And in this version, the game is played on a 9 by 9 board, which I manage using a two-dimensional character array. So let's jump in and take a quick look at the application. So I'll start, go into main, we'll run it. So as you can see, I could select from either a two-player or a player versus AI version. Uh, this is the main game window built using Java Swing. The board is rendered, as I said, using a two-dimensional grid of buttons. When I click on a square, it places either a B or a W for black or white, depending on the current turn. I will first click on the two-player mode. Two-player mode, I will choose black, and there's the board. In the two-player mode, players alternate turns. The application handles validating moves to make sure a square is empty before placing a piece, switching players after each valid move, and detecting if someone has won. So let's try, make sure we can play. So there, I'm playing as black. Say I'm playing against someone else. They would click as white. So I can pretty much put these pieces anywhere I wish. But the goal is to get five pieces in a row. Boom. B wins. Once a player aligns five in a row, a message is displayed showing who won, and the game ends automatically. So that is the two-player version. Now I will rerun the game, and let's try to see how we can play with AI. So the AI version has actually easy, medium, or hard. Let's try easy first. So the game features AI functionality using the Minimax algorithm with alpha beta pruning. This allows the AI to evaluate possible moves and choose the most optimal one, simulating human-like strategy. Alpha beta pruning improves performance by eliminating paths that don't need to be evaluated, making the AI fast and responsive even on a 9 by 9 board like the one we're currently playing on. So I'm going to play quickly on easy mode. Let's see. So it's randomly selecting where it's going to put them. Very easy for me to win here. Let's rerun it. Let's try to play, see if it gets a little bit harder. So let's go medium. beat me. Medium. James wins. Let's try hard. See how hard this is. Sneaky. Trying to beat me, buddy. Interesting. So as you can see, it's a little bit harder now. And I tricked you. Haha. So the AI's decisions are based on simulating possible player and opponent moves, scoring the board states, and minimizing the worst case scenario. This component shows how AI and game theory can be integrated into traditional board games using recursive algorithms and heuristic evaluations. So let's take a quick look at the code to understand how the application is working under the hood. This is main, where we run the program from. It's the entry point. It launches the GUI on the event dispatch thread using Swing utilities invoke later, which is standard practice for GUI apps. And let's go to board Java. Here, the board class manages the game logic and the 2D array that stores the current state. It handles initializing the board, placing valid moves, and checking for a win in all directions, horizontal, vertical, and both diagonals. Game GUI.java. Here you can see the Minimax algorithm. Here, this class controls the interface. It uses a J panel with a grid layout to render the 9x9 board. Each cell is a J button, and clicking it triggers the game logic. The GUI dynamically updates after every move and shows pop-up messages for wins and invalid moves, as you have seen. Working on this project helped me strengthen several core concepts. I deepened my understanding of data structures by managing the board using 2D arrays. I practiced object-oriented programming by separating concerns into classes like board, game GUI, and main. I implemented AI using Minimax and alpha beta pruning, learning how to simulate strategic gameplay, and I gained hands-on experience with Java Swing, event-driven programming, and building responsive interfaces. That wraps up my walkthrough of the Gomoku game with GUI. If you have any questions or want to see the code, feel free to check the description below. I hope this project gives you some inspiration for building your own Java games or experimenting with AI in simple applications. Thanks for watching, and I'll see you in the next video.